Good day, this is Professor Will, CBMD PhD. Today's Friday, June 4th, 2021. It is 2:10 and 39 seconds, p.m. Eastern Standard Time. Today's research, Biocompatible Hydrogel. So let's hop to it here. Biocompatible hydrogel materials can rapidly recover from mechanical stress. Date June 3rd, 2021. Source, University of Tokyo. Hydrogels are polymer materials made mostly from water. They can be used in a wide range of medical and other applications. However, previous incarnations of the materials suffered from repeated mechanical stress and would easily become deformed. A novel crystal that can reversibly form and deform allows hydrogels to rapidly recover from mechanical stress. Many of us suffer the occasional sports injury or experience some kind of pain relating to joints and ligaments at some point in our lives. For serious injuries of this nature, there is often little that can be done to repair the damage. But a new development in the field of water-rich polymer materials, known as hydrogels, could find its way to the operating room in around 10 years or so. And they should stand up to the same mechanical stresses our natural joint and ligament tissues experience too. They are called self-reinforced gels. The problem with existing hydrogels is that they can be mechanically weak and so need strengthening. However, previous methods to toughen them up only work a limited number of times, or sometimes just once. Those gels do not recover rapidly from stresses such as impacts while at all. So researchers looked at other materials which do show strong recoverability, such as natural rubber. Taking inspiration from these, researchers created a hydrogel that exhibits rubber-like toughness and recoverability whilst maintaining flexibility. Previous examples of toughened hydrogels use so-called sacrificial bonds, which break when deformed. The destruction of the sacrificial bonds would dissipate mechanical energy, giving the material strength. But the sacrificial bonds would take time, sometimes minutes, to recover, and sometimes they would not recover at all. In contrast, a research team introduced crystals which assemble into rigid shapes under strain, but very quickly revert back to a gel state when the strain is released. In other words, the overall hydrogel is extremely flexible at rest, but firms up on impact, much like natural rubbers do. The crystalline structures are composed of polyethylene glycol, PEG chains, bound by hydroxypropyl, a cyclodextrin, HPACD rings, and a water-based hydrogel. As hydrogels are over 50% water, they are considered highly biocompatible, essential for medical applications. The next stage of research is to try different arrangements of molecules. If we simplify our structures, then we can reduce the cost of materials, which will also help accelerate adoption of them by the medical industry. Good day, this is Professor Will, CBMD PhD, on microbiology, bioinformatics, and pathophysiology. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.